Good morning, Dr. Juman. My name is Yen Thong and my team members are Chia, Liang and Low Tzi Wei. Today we are going to present about the final product for our assignment 2. Firstly, we will have two Python files, which is the different solutions that need to be applied on the images, and also the similarity Python file to check for the similarity between the original image and also the restored images. To run and check for the results for the Python files, we need to use the command prompt, and we can go to the location for our file. We use the command cd and following by the address of our file location. Then we can check for the solution 1 first. We go to the restoring 1.py, which is the file name for our first solution. Following by the image name that need to be restored, which located in the noise file. And here we will use image B7 to do the demonstration. So we type img b7.jpg. Following by the restored file that need to be located in the file name restored. And this will be the name of our resulted image, restored img b7 solution1.jpg. Then we press enter and we will get the two images, which is the noise image and also the restored one. And if we want to check for the similarity, we can type similarity.py following by the original file, which is the expected result for our image. b7.jpg and also the restored image. img b7 solution1.jpg. Then we will get the two images, which is the expected result and the final result that we get, and also the percentage for the similarity between these two images. Same for the solution 2, we can type restoring 2.py following by the noise image img b7.jpg and also the restored file start img b7 solution2.jpg. Then we will get the noise image of B7 and also the restored image. Then we can use the similarity file following by the original img b7.jpg and let it compare with the restored file. img b7 solution2.jpg, and we can see the comparison between the expected result and also our final result, and also the percentage of the similarity between these two images. Next, I will pass to my team members to explain our solutions. Thank you.
Hi, my name is Debbie and I'll be talking about the explanation for solution 1. So solution 1 has 3 main steps. So after the program reads the image, they will apply the first filter, which is the 7x7 median filter by using the median blur function. So this process is used with a parameter where the kernel size is set to 7. So the resulting image will be stored as filtered image. After that, the program will then apply the add function onto the image, the filtered image, in order to increase the value of the pixel by the constant C, where our C is the value of 5. So this is to increase the brightness of the image so that it can be a little bit nearer to the expected result. So this will be stored as filtered image 1. After that, the filtered image 1 will then again be applied with the median blur function, where the kernel size is also set to 7. And after this, the resulting image will be stored as filtered image 2. And then it will be written and saved to the output file. So that's all from me. Thank you.
Very good morning to Doctor. I'm Chia Liang, and I will now explain about the solution 2 of our program. So let's go to the main function. In the first, we declare images and file to be empty. So we input the value of files in the command prompt. We use the process command line function. So the file 0 is the input that we from the noise image, and the file 1 is the output, which is the result image. So in the first, we just read the noise image first and then save it into image 0 by using cv2.mread. And then we process our solution 2 by input the image 0, and then we output the file to the output the restore image to the file name from the file 1. And then for the image 1, we read from the output file name. So we use cv2.mread. So now we got the input image and also the restore image. So we display together to see the comparison between it. So this is for our main function. So for the display function and also process command line function, we take it from the similarity.py. So now we just focus on the solution 2 function. So in solution 2, we use a non-local means filter, which is this one, fast and L means denoising. So for the first thing that we need to do is to split the image into 3 channels, which is B, G, and R. Because that this non-local means filter is used for a grayscale image. So since our image has color, so we need to split the image into B, G, and R and apply the non-local filter to each channel to the B, G, and R. So the first one is the input B, which is the channel G and R. And the second parameter is actually the destination. But since we use B equal to the result of this, so the parameter for the destination we just put none. So for the C, it is actually the denoising the filter strength. So the higher value of C, we can get a great denoising result. So we can denoise the most the salt and pepper noise, but at the same time, the higher value to C, the details of the image will be reduced. So how do we determine this value of C is we need to try and error to see which value of C give us the most uh, denoising effect, but at the same time preserve the details of the image. So for the 7 and the 21 is the parameter for the template window size and also search window size. So for this one, we just take the recommended value, which is 7 and also 21. So after we done the non-local mean filter, we go to the we need to merge the image first because we split it to the BGR. So now we need to merge the channel back into a single image. So we use cv2.merge. The input is BGR. So after we complete this, we use the cv2.add function to increase the value of each pixel in the image. So the value we use is 5 to make the image become brighter. The reason behind it is to increase the similarity for the image B and image C. because the original image B and image C is quite a bright image. So after we done the means filter, so the value of pixel will become average, so it will become lower for the bright image. So we need to add uh, five value to each pixel, so the restore image will become brighter, so the similarity will become higher compared to the original image for the image B and image C. But for the image A, the similarity actually become lower because originally the image A is a quite dark image. So when we brighten the image, so the image A will become the similarity will decrease for the image A. So after we done all the process, we save the image to the file 2, which is the input of here. So this is the file name of our output file. So now I will demo the result image by using similarity.py to compare the similarity between the original image and also the result image for the solution 2. So first we go to the command prompt. So we need to list cd to our original image to the file destination. So for the first one, we use for the image A. So we can see that this is the original image and this is the result image for image A. So we only get 11.98% for this. The reason behind this is because the original image for the image A has a very dark background. You can see all black here and also a very bright object. So when we apply the mean filter, the pixel value will become average. So we can see the background become brighter and also the object become darker. So the difference between the background and the object is the value of the pixel difference is too big. So when we apply the mean filter, the result is not that good, and then so the similarity will decrease. And also we also apply a add image just now. No, the add function just now here. So actually the restore image become brighter. So the the similarity become very low, which is 11.98. But we can also run this program one more time. But this time we push a threshold value of 20, so we can see the similarity has increased to 63.28, but it is the same image. The higher the threshold value, so the similarity.py program can tolerance with a bigger difference of the value of the pixel. So we actually can achieve a higher similarity because we can see although the similarity is very low and the threshold value is 10, but we can see that the most of the salt and pepper noise has been removed and also the details of the object is still preserved. So actually the effect is not that bad, just the background become brighter, so the similarity has decreased until 11 point something just now. So we use the threshold value of 20, we can see that the similarity has increased to 63.28. Now we run the image B using the similarity.py. So this is our result. This is 75.53% similarity by using the default threshold value is 10. So we can see most of all the salt and pepper noise has been removed, and also the details of the image is still there. So it's quite similar to the original image. So that's why we get a higher value of similarity. So we run the third one, which is the for the image C. Sorry. So we can see that this is the result is quite similar to the for the with the image B. So the similarity is 69.57. So the image is still detailed, and also we remove all the salt and pepper noise. So the reason why this function is good, the mean filter is good, achieve a good result for the image B and image C, because you can see that the original image has a bright bright background, and also the object is quite bright. So the difference between the object and the background don't have a huge difference of the value of the pixel. So we use the mean filter, we get the average value for each pixel. So the difference from the original will not become so huge. But for the image A, since the background is very dark and the object is very bright, and we apply the mean filter, so we take the average value will have higher difference from the original image. So that's all for my presentation. Thank you.